We are going to continue the last PPT. So the file handling as regular expression, working with files and searching text efficiently. So far the program data vanished when the execution ended. In a real application we store, retrieve and validate information precisely. This unit teaches Python file, read, write and close. It introduces regular expression for powerful text and search validation. Real world examples: student database, hospital records, banking transaction, login data, and log file all rely on file handling text search. So basically, in this unit, we are going to study about regular expression, working with files, searching text efficiently, and basically we are going to learn about file handling, data type, and text efficiency. So moving towards the next slide, which is what is file handling. File handling is a process of creating, reading, writing, updating, managing file from your program. File let your program keep data between runs instead of losing when the program exists. Without file, data lives only in a memory, lost on exit. With files, data is stored precisely on disk and can be reused later. Common uses: reports, logs, user data, configuration, backups. So basically, what is file handling? File handling basically it is in the three parts. Without files, first we will learn about without file, data lives only in a memory, lost on exit. Just when we will just we are writing something on a notepad and we will just not save it. We will not do it as a save as, not create a file of it. It will not get saved in our memory, and as I just close that window, it will just vanish. But when I use save as and store it in a file format, then it will be it can be reused and can be used later on when I needed it. Basic common uses: report logs, user data, configuration, and backups. So basically this is the use, this is the flow diagram. Okay, this is how you make it. Okay, so I guess moving towards the next slide. Opening files as file model modes. Modes meaning R equals to read file must exist. W write creates or tran creates file. A append adds to end. X creates a new file. Fail if exist. Reads write no transcription. Example: if file equals to open student.txt R, always pick the mode that matches your internet. Accidental W can erase data. So we will move next slide. Okay, reading file. Python offer multiple ways to read file connect depending on your needs. File read the entire file as a one string, useful for small files. File reading reads a single line at a time, used in a loop to process line by line. File readiness returns as a list of line, handy for simple list based processing. Quick example: with open student.txt as f data equals to f.read. Using the with statement is recommended as seen next card. So basically we will learn Python offers a multiple ways to read a file content depending how you need it. So file read is the first way to read the entire file as a one string, useful for small files. File read line single line at a time, useful for loops, process line by line. File readiness returns as a list line, handy for a simple list based processing. With open student.txt as f data equals to f read, using the statement recommended for the next card. So basically it's about the Python uses three ways: file read line, file read line. So basically it means a first one uses a one string. Okay, so it is used for one file. Second is you line by line, and third is list based processing. These are three processing. Okay, we will move to the next slide. Okay, writing and appending files. Writing replaces contents, appending adds to the end, knows the difference before you open a file. Writing override file equals to open student.txt w. This mode deletes existing contents, writes a fresh data. Example file dot write hello Python. Appending preserve and add file equals to open student.txt a. This mode adds data to the file without removing existing data. So basically there are two types. Writing override, basically we will overwrite the data on the previous file which we already have, and appending preserved as add. Basically in preserving, having the old file, not touching it, and just adding it, not overwriting it. So these are the two ways where which they can help. So use W carefully. It translates use A when you want preserve prior records. Example, appending a new student entries. So W is carefully for transcripts, basically to change the data, and A for the preserving the prior records. So I guess this part is also clear now. Okay, so I will just move towards the next part. Choosing file as the with statement. Always release file resource when done. The simple method file.close. Preferred modern pattern with open student.txt r as file content equals to file.read. Benefits of with automatically closes the file even on errors. Cleaner, less error prone code recommended for IO files. Okay. Closing file with the statement always release file resources when it's done. So basically we just use this simple method preferred in the modern pattern. We just use file close for the in the modern patterns with open. So this is the code. Basically its benefits are automatically closes the file even on errors. It will just close the file even if it has errors in it. Cleaner and less error prone code. So it will just don't create a code for you, it just help you to have the less error in the code. Recommended for all IO files. Basically in the modern patterns we use it as it doesn't give much errors as previous codes as previously that was given. So let's move towards the next. Okay, move towards the next slide. Introduction to regular expression regex. Regular expression regex are compact pattern that describe sets of string, and they let you search, validate, and replace with precision ideal emails for phone numbers, password, and a long praising email validation. So what should I say? Email validation use regex to check shape like user domain before deeper validation. Phone number normalize and validate phone formats for many sources, and password rules enforce presence of digital uppercase special characters with one pattern. So basically these are the three validation. Email for regex to check the shape like users domain, and for the deeper validation phone number validation for the normalize and validate phone formats for many sources, and last is password rules enforce presence of a digital uppercase special character with one pattern. So these are some basics regular expression regex. I guess this part is also clear now, and I guess basically it's for the protection, for the security purposes also, and it make easy for you to basically understand what basically it is used for making your account more secure, more secure, more easy to accessible only for you, not for anyone else. So let's move towards the next part. Start with import re.key function usually frequently. Function purpose: search, find the first match anywhere in the text. Match checks for a match at beginning of the string. Findle returns a list of all non-overlapping matches. Sub replace match text with a replacement string. Okay. Example re.findle Python text returns very occurrence of Python. Regex power grows as you learn character classes, quantifiers, groups, and anchors. So in this part we are going to understand common regex function. So basically these are the four functions. First is search, find the first and match anywhere in the text. Second is match, check for match at the beginning of the string. Okay. Findle returns a list of all known overlapping matches. Okay. And the fourth part is replaces matched text with a replacement string. So basically, I guess you have basically understood what it means. And this is the one example they have also given. re.findle Python text returns every occurrence of a Python regex power grows you learn character classes quantifies group and anchors. I guess this part is also clear now. Moving towards the second last slide of our PPT. Mini project student record system walkthrough. First we will build a compact program, add, save, read and search student records using file and regex name matching. Okay. The student details name, ID, email for user input to validate with regex, write file, open file and append made and write a new file, new line per student structure format CSV or JSON line. Read file, open file, read mode, load lines, trace each record for display searching, search, use regex, research and find the name for the partial matches to displaying matching records. Okay. Flow input, write file, read file, search, display. We will implement this live after the slide. You can follow along. So this is the mini project you can guys make. This is how we should work with it, and I guess it's clear now. Moving towards the last slide. Congratulations. The unit summary, you need to understand preset data with files and how search, validate using regular expression. These skills are built practical program that store data, uses process logs and validate input reliable. Key takeaway, use correct file, modes prefer with statement, understand, read, write, append, validate input with regex. Next steps, build a mini project, practice regex pattern and explore CSV JSON modules for structured file. Python docs open with remodule tutorial, example with projects and exercise. You all covered the full course map including earlier variable, data type, OOP and added file as regex of a toolkit. Well done. You are ready to create to write program, process data and intelligently analyze text. Thank you. We are going to continue the video, and now we are going to study object oriented programming, OOP. So let's start. So what's OOP mean? Writing program like a real software developers. Okay, so far we have written programs line by line. As a project grows, that the approach becomes hard to maintain. Object oriented programming help us to structure code around real world concept by grouping data and behavior into objects. This makes program easier to build, read, test and extend. Student management system, hospital management system, banking app, Instagram, Amazon, all these are the system benefits from the OOP principles. Reusable blueprints, classes, well insulated data and clear relationships between components. So basically what's object oriented programming is? So object oriented programming basically mean now we have to going to code like a programmer. We are going to think like a programmer now. So this is how it works. So what should I explain? What should I explain? Like these are some projects which as a developer I can make and I should build to at least stand out. So these are some systems: student management system, hospital management system, banking app, Instagram, Amazon. These all are made by programmers like you, like me, as we are going to become a software engineer soon. So I guess it's in this PPT we're just going to learn about how should we objectify, like how do we have to code, how do we have to think that by this roadmap we are going to make our project. So basically we will learn about that in this video. So let's start with the first slide. What is OOP? Object oriented programming. is a programming paradigm that organizing code using classes and objects. Think classes as a blueprint and objects as the real world instances built from those blueprint. Class, a blueprint that defines attributes, data, and a method's behavior. Second, object, as an individual instance created from a class. It holds state and can act. Example: real world car, class, blueprint, object, my underscore car, a Tesla red. Okay, so how does it work now? We are going to learn about it. So there are three types. We have to basically learn three objects. First is class, a blueprint that defines attribute, data, and methods behavior. Second is object, an individual instance that creates from a class. It holds state and can act. Basically, what should I explain? It basically means first we have to create a blueprint, basically data and method we are going to use. Object, a individual instance that create a class. So like we are going to talk about car in this example. So basically a Tesla car which is red in color. So real world example, so it is a real world example car. In the class is car blueprint. My object, what is my object? A car, and bracket like how I wanted. So a Tesla red, a Tesla car in a red color. So this is how we create, how first we lay out our plans to code. Let's moving towards the next slide. Class as object as connect examples. A class defines the structure. An object is an concentrate instance. Use class to a model concept. An object to hold actual data your program uses. Class basically is a blueprint. Example, in a Python class student pass. This declares that a student exists but does not create one yet. Okay, so basically just think about like you are not present in this class today, but in the system, in the computer system, you basically are the part of this section, this class, this college, and this is your registration number. So basically a blueprint is something which is not done yet, but it's a prototype for it. Object instance, create an object s1 equals to student. S1 is a concentrate student, so you can work within code. So now we have created S1 equals to student. So basically now that student, like which I have given example that you are not present in the class. Now think you are in a present and you have just just like student number 1, your roll number is 1, so your student just S1 roll number 1 equals to Moksh Tyagi or Isha Rathore. So this is how it works. I guess this part is clear. Moving towards the next part. Constructor dot underscore init. So a constructor initialize an object where it created in a Python, and constructor method named init, and it set up initial state. So each instance has its own data. Example, class student def init equals self dot name equals to name. Or create an object s1 equals to student Isha. Constructor runs an automatically and sets s1 name to Isha. So basically what does it basically it's explaining class student def init self name. So class student, so like my class student is talking about me. Def init self name is equals to Moksh. I will just write my name here. Self name. If I just write self name and equals to my name, so basically it created my object my init. So basically this is the example. Create an object init s1 equals to student Isha. Just I will just replace Isha to my name, which is Moksh. So it will work when I will just write s1 dot name. It will give me Moksh, or in this example Isha. Constructor reduce repeated setup codes and make object creation predictable. So this is how it works. It make your code predictable, more understandable, and justify what you want to explain and whom you are talking about. Okay, so I guess this part is also clear now. I guess I should move to the next slide. which is the self keyword. In Python, the self refers to the current object. Instance on object which method is called. It is how the method access and modify that instance attribute. Why self? Self Python cannot distinguish between class level names and instance data. Self.name explicitly refers to the object name attribute. Def set age self comma age self age. So basically we just use self. Python cannot distinguish between class name, level, and instance data, self name. So that's why basically Python cannot distinguish between class level and names. So that's why we use self name. So like I want to use my self name, so self name equals to Moksh. For age, self age equals to age. So this is how we set up it, and and first of all we should know that what's the definition of it. So in Python, self refers to the current object, like current object is me right now. Instance on which a method is being called. Instance, basically what is instance? This self.name. Then how it method access and modify that instance attribute. This is how it works. Def set age self comma age self.age equals to age. This is how the code works. This is how it give you the output. I guess this part is also clear now, and basically it's this part is very easy. This part is very easy to learn. I guess it's not very hard for you guys to understand. I will just say it will just take few minutes for you to learn, to understand what the Python is very easy. Yeah, Python is very easy language. We have to just remember some basic command, basic attributes. So we can write a whole code, whole program by it. So let's move towards the next slide. Okay. Encapsulation, protection data. So it bundles the data, attribute, and the methods that operate on that data into one unit. Class, it hides internal details and exposes a clean interface, improving security and maintainability. So basically what does think this is the capsule. Basically this is the capsule. So think these are the meds which is inside it. So this protection cover, which is outside layer, is protecting them from getting lost or coming in the contact in the air, which will reduce the benefit of this medicine. So basically this is how the data works only. So think like you have used the password, but you have used double encryption, two-step verification on Instagram, like we have password, then we use two-step verification, so the hackers cannot easily get into your account. This is how it works. Benefits: security, control, access to the sensitive attributes, better organization related to code group together, easy maintenance, change implementations without changing interface. So these are some benefits. Example pattern: use private attributes, convention, prefix with underscore, and provide method to access, modify them safely. So basically big organization use this method, which help them what should I tell you, which help them not getting their data leak, and easy to understand for the other coding who is working on the same project, and it is easy to maintain. Like if I just working in a firm and I just did this whole coding, but then I just left that company and the project is incomplete till yet, then another person who just joined, how will you know that this part what you have done, which line means with which line attaches, which line is attached with this line, and how the code is working. This is not how it works. So that's why this type of method is used. So for security, control, sensitive attributes, better organization use this type of code, easy maintenance. This is the example which I guess I've already explained you guys. So we are moving towards the next part. Inheritance and reuse as specialization. So what is inheritance, reuse, specialization? Inheritance lets one class child acquire properties and behavior from another class parent It encourages code reuse and lets you specialize with behavior for subtypes. Basic syntax: class animal, def breathe self, class dog animal, def bark self. Okay, so basically class is animal, def breathe self, like he breathes, he she breathes, class dog animal, def bark. So it is basically tell about like this is animal, this is the parent code, this is dog, which is a child code. Animal breathe is the part of the parent part, and this def bark is the part of child. Code reuses shared attributes method live in the parent, let duplication and implementation different reduces in subclass. By this, code reuses shared attributes method live in the parent, lets duplication only implement differences in subclasses. Okay, so I guess this part is also clear. Moving towards the 8th slide. Polymorphism, one interface, many behaviors. Polymorphism means many forms. The same method or interface can behave differently depending on the object that implements it. It simplifies the code that works with the multiple types. Example: class bird, def sound self pass. Different subclass implement sound differently. Robin chirps, crows claws. Okay, so what does it basically mean? Polymorphism basically this basically means many forms. The same method or interface can behave differently if depending on the object implemented, and simplifies code that works with the multiple types. Like for example, class bird, def sound self pass. The different subclass implement sound differently. Robin chirps, crow crows. So basically, if I just put Robin chirps, crows, caws differently, it will give me different sound when I will run it. So what is method overriding? A subclass provided to a new implementation for the method defined in the parent code. That calls method doesn't know which subclass its behavior adapt automatically. Okay, so this is how it works. I guess it is clear. Basically, polymorphism basically works differently with every subcode. The subset, it will act differently. Like the main set is a bird, but it will act differently when I put Robin chirps, cows and caws in at the point of subcode. It will act differently. So many projects, student management system live coding. So basically now we are on the example part. What should you guys can make by your own, and how it's easy to build it. We'll build a simple student management system to practical OOP concepts. The system will demonstrate class design, objection creation, encryption, and a simple method for input display. Student class object creation. Third, input name, roll number, marks. Fourth, store in list. Fifth, display details. Add student, add a new student's detail to the list. Display student, display all student details from the list. Calculate average, calculate and display the average marks. Student class object creation, input roll number. So this is how the student management system works. Basically it works. Basically we will start from student class, then we will do the object creation. Basically like student class, like my roll number, my registration number. Then I will move to my section. Then I will put name, roll number, marks. Okay. Then I will store it in a list. Then I will upload in a display details. So basically these are the sub parts of it. Add student, display student, calculate average, and it will basically in our college we have a UMS, which we are all aware about, and the LP touch also, which basically works in. This is how it works. This is easily explained, you guys. It is very hard to make it for the bigger level, but for now, for smaller level, you can easily make it. It's not very hard to make it. So moving towards the last part. Okay, summary, homework, and next unit. The key concept: class blueprint for object runtime instance. So basically, class blueprint for the object runtime instance, constructor init है, initialize state, self it's refer to the current object, encapsulation, bundle as product data, inheritance, reuse and specialize, polymorphism, same interface, different behavior. So basically this is what we have learned in this unit, and I guess it's not very hard for you guys to understand it, and you will easily grab these things, as it's not very hard. Now what you have to do in the homework, and what we will going to study in the next unit. So create an employee class with the name, ID, salary, and method to display details. Create a car class with make, a model, year, and a method to calculate age. Create a mobile class modeling basic phone features and a method to make all call print statement. Create a bank account class, deposit, withdraw, and a balance check methods. Enforce encapsulation for a balance. Create a library book class, a title author, it is checked, and out of method. So basically, I guess you have all understood what we have learned in this part. Bring your completed code. In the next session, we will review the implementation refactor using inheritance, where appropriate extend one example into a small project. So I guess this part comes to an end by this last unit, by this last slide, and I hope you guys understood what I explained. We will do the quick revision in the next part, I guess, or let me know if there any doubt. Do comment in the video. Thank you.
So, good evening everyone. So, we are going to start the unit 3, which is operators and decision making. Until now, our programmers could only store information and take input, but they couldn't perform calculations or make decisions in this unit. We will learn how the Python calculates value using operators and make decision using conditions. Two of the most powerful building blocks in the program all of programming. By the end, you will be able to write the programs that evaluate conditions, compare values, and branch into different paths, just like the real world decision making. So basically we are going to learn about operators and decision making in Python language. Basically in the previous units we haven't learned how to write code, how to write a program actually, and how to take a decision while writing the code. So in this unit we will learn basically we will learn about this only. So let's start. So first of all, what are operators? Operators are special symbols used to perform operations on variable and values. Think of them as the verbs of the Python language. They do things to your data. The simplest analogy is a calculator. When you press the calculator adds two numbers, Python operates works the same way, but they can do far more. Basic example: 10 plus 5, 15, 20 minus 8, 12, 5 multiplied by 6 is 30, 12 divided by 3 is 4.0. So, and the idea in one line: every operator takes one or more values called operands, applies a rule and produces a result. The result can then be stored, printed, or used in a further calculations. So basically, what they are telling in this part, operators are special symbols. Operators basically are a special symbol that define a what should I say? Define a work. So if I want to add something, I will just write a plus symbol between two digits. Or I want to multiply, I just will use the star symbol. Or if you want to multiply, then I'm gonna use this star. Then if I want to subtract something, then I will just use the subtraction sign. So basically it performs many work for us. So basically this is, I guess it's clear now. So I guess we should move to the next slide. So arithmetic operators. Arithmetic operator lets Python perform mathematical calculations on numbers. Here is a complete set you need to know along with the example and result. Operator. First of all, we should know what operators are, what type of operators are actually. So first of all, we have addition. So second is subtraction, third is multiplication, fourth is division, fifth is floor division, and sixth is modulus, seventh is exponent. So these are the signs which we have to use to basically when we are writing a code. We cannot just write addition, subtraction, multiplication. We cannot write that. So in case of that, we have to use them to the system know that we want to multiply, add, or subtract something. For example, addition 10 plus 5 is equals to 15, subtraction 10 minus 5 is 5, and multiplication 10 multiplied by 5 is 50, 10 divided by 5 is 2.0, floor division 10 divided by floor is equals to 3, modulus 10 percentage 3 is equals to 1. Exponent power 2 multiplied by 8. Okay. This is basically a mini. So what we have to do in this unit, basically take a mini challenge. What is the output? 17 is to 5. And modulus give the remainder after division. So it's a basic thing. I guess operators is a very easy thing to learn. Basically, you have to remember these for the arithmetic operators, and in this unit we will learn more operators and their work. So I guess we should move on to the next slide. So assignment operators. Assignment operators store a value into a variable. The most basic one is equals to, which assigns the value to the right to the variable on the left, but the Python also provides compound assignment operators, shortcuts that combine a calculation with an assignment in a single step. Let's start with x equals to 10 and then apply each compound operator in a sequence. Watch how the value of x changes after each operation. So basically, I guess it's very easy. I don't think so. We have to I don't think so. We have to worry more about it. So let's, I guess, move on to the next. X plus 5 equal to 5. X equals to x plus 5. Then, so what happens before x plus equals to 5? 10. And after adding x plus 5, what happens? It's 15 now. X minus equals to 2. So basically it's 15. And afterwards writing this equivalent, it's 13. Same with these two also. So these shortcut key make your code cleaner and especially useful inside loops where the variables is updated repeatedly. Okay, so next is comparison and logical operators. Comparison operators are compare two values and always return a Boolean result, true or false. Logical operators then combine modify those Boolean results, letting you build complex conditions. Comparison operators, logical operators. So comparison equals to and not equal to, less than, greater than, less than or equal to, or greater than equal to. These are the basic comparison operators, and these are the logical operators. So what are logical operators? And true if both sides are true, or if either side is true, not reverse the true false. So these are the basic comparison and logical operators. I guess they will be used in the mathematical terms, basically more time in the mathematical terms, and this should be used in the theoretical knowledge. For example, the expression marks is greater than 40 equates to true marks if 40 is above 40 and false otherwise. You can chain conditions marks greater than equals to 40 and marks smaller than equals to 100. Checks that if the marks fall within the valid range. So basically these are the operators which is used to basically tell the marks, digits, sum, and logical operators help into with the each side true or false conditions. Actually I'm not well, so that's why I'm not able to explain properly these things. Otherwise I would have tried more. So identify and membership operators. Beyond arithmetic and comparison, Python provides two more categories that are incredibly useful everyday code. Identity operators is not check whether two variables point is to the same object in memory, not just the whether the values are equal. X equals to bracket 1 comma 2, y equals to 1 bracket 1 comma 2, x equals to y equals true, x is y true, membership operator, and a membership operator in and not in check whether the value exists inside a sequence like a string or a tuple. Python in Python codes 2, 5 in 1, 2, 3, 4, 5 true. Bitwise operation. These are the terms and work in a binary representation of numbers. We'll touch on them only briefly as they are an advanced topic beyond our current scope. So I guess it's clear now. I don't think so. There is much to explain it. So let's move on to the next slide. Decision making with if. What is decision making with if? Continue flow with proceed after branch, no skip block, bypass when false, yes execute block, run code when true, check condition, evaluates boolean expression. So this is the chart which I guess you should know to how this pyramid work. So check condition, evaluates boolean expression, yes execute block, run code when true, no skip block, bypass when false, continue flow, proceed after branch. Programs need to make decision just like do. If it's raining, take an umbrella. In a Python, then if statement evaluates a condition, executes block of only if that condition is true. If the condition is false, then block skip entirely. I guess there is some little bit of code. Here is a real example checking whether the student has passed. Marks equals 25 if marks is greater than equal to 40, print pass. So this is how it works. If I scored more than 40, then I am pass. If I scored less than 40, then I am fail. So this is how this if condition works. If else if as nested if. If the if statement is just being beginning, Python offers a family decision making structure that handle increasingly complex scenarios from way to branches to multi-chain decision making with decisions. Okay, so if I start with from the bottom, if else two-way branch decision, else if chain, add middle branch option, nested if decision instead of branch, progressive logic combines for complex flow. If one condition, one execution executes only if the condition is true. If else two paths, one for true, one for false, always block runs. Elif, multiple condition checked in order, first match wins. Nested if, and if inside another if for decision, prior decisions. to put everything other, we will solve these programs live writing and running real Python code. Each are perform different combination of operators and decision making structure. Even or odd, use the module operators to check if a number is divisible by 2, positive or negative, compare a number against 0, greater than and smaller than operators, largest of two numbers, use an if-else statement to compare two values and find bigger one, largest of three numbers, extend the logic with elif and nested if to handle three inputs. Grade calculator chain multiple elif branches to assign grade A through a F based on marks. Voting eligibility, check a age greater than equals to 18, comparison on logical operators together. Simple login check. Combine and logic to verify both username and password in one condition. So I guess it's clear now. First is even or odd. Even odd use the modules operators percentage to check if the number is divisible by 2. So even odd is checked by when if the code is if that value is divisible by 2 or not, positive or negative, compare number against 0 using greater and smaller operators, largest of two numbers, use an if-else statement to compare two values and find the bigger one. This is how it works. Largest of the three numbers, extend the logical if-else nested if to handle three input. Grade calculator chain multiple elif branches to assign a grade A through a F on marks. Check age equals to 18, comparison and logical operators together. This is how it basically works, guys. And I guess this unit is completed now, and I have explained everything. We will come back in the second part of this video and continue this